Hello, greetings, and welcome. In this screencast, we will work through our first example from week 4, in which we continue our journey through Chapter 2 on an introduction to linear programming. And so specifically, we're still going to work on example problems from section 2.2 on applications of linear programming. So in this specific example, we will work on a multi-period scheduling problem. In this first screencast, we will set up the problem, and then we'll have a follow-up screencast in which we numerically solve using Excel. So the problem's a little more involved than some of the problems we've worked through in the past, but key will be just to take it step by step. Okay, so without further ado, here we go. So a company is planning the manufacture of a product for March, April, May, and June of next year. The demand quantities are 520, 720, 520, and 620 units respectively. The company has a steady workforce of 10 employees, but can meet fluctuating production needs by hiring and firing temporary workers. The extra cost of hiring and firing a temp in any month are $200 and $400 respectively. So it costs $200 to hire a temp and then $400 to fire. A permanent worker produces 12 units per month, and a temporary worker lacking equal experience produces 10 units per month. The company can produce more than needed in any month and carry the surplus over to its succeeding month at a holding cost of $50 per unit per month. Develop an optimal hiring-firing policy over the 4-month period. Okay, so we're asked to formulate the linear programming problem and then solve. Alright, so the key is going to be to take this step by step. Okay, so let me see if I can't get a red cursor here. Okay, so the first thing I'm going to do is I'm going to label my months, so rather than keeping track of them. So let March be month 1, April 2, then 3 and 4. Okay, so we're producing product over this 4-month period. We're given our demand, okay, and so we'll take this as how many units need to be delivered in month 1, 2, 3, and 4. Okay. So we have a steady workforce of 10 employees that can produce 10 units per month. Okay, and so those are permanent employees, so we'll take that to be a fixed cost. Okay, and so our fluctuating cost that we're going to seek to minimize is going to be that cost of hiring and firing a temp employee in a given month, and then also the storage cost. Okay, so our goal here, as being a production problem, is going to be to minimize our cost, and our costs here will be due to the cost of hiring and firing temporary employees to meet demand, and then also storage cost. Okay, so let's start by defining some variables, and then let's write down our objective function, and then try and go through and figure out exactly what we have in terms of constraints. Okay, so first let's define some variables. And I'll switch back to my black pen. Okay, so let's define some variables here. Okay, so in terms of variables, okay, so we said what we're going to be solving for is the number of employees we're going to hire and fire in a given month. So let's let xi be temps hired. Okay, and I'll say temps hired at start of month. Okay, we're going to let yi be temps fired at start of month. And I'm going off of the start of the month because I'm going to need to hire those employees at the beginning of the month. So say it's even just the first month, March, I'll need to say first start by hiring some temps to meet demand for the month. All right, and then I'll, just as well in a subsequent month, if I have too many temps, I'll start by firing them at the beginning of the month, so I have the proper workforce beginning at the start of the month. So that's xi, yi. We won't use z. So in terms of thinking about inventory, excess inventory at the end of the month, let's use wi. And so wi will be say excess inventory our excess product and to go to storage. At end of month. Okay, so I can produce a certain number of product in a given month, and then the excess I have relative to the demand, what needs to be delivered, I'll put in storage, and then I'll have that as a beginning balance at the beginning of the next month. Okay, so those we'll use those as our variables, xi, yi, and wi, where I is going to be 1, 2, 3, or 4, just an index to correspond to March, April, May, or June. Okay, cool, right? March, April, May, June. So my objective is to minimize my variable cost. Okay, and what I mean by that is we have a fixed cost, which is the number of employees, okay, my number of permanent employees. So I have a fixed cost, which is the number of permanent employees. And so our variable cost, as laid out in the problem, is going to be, our hiring and firing of temporary employees to meet demand, and then also the storage cost. Okay. And so if I were to write this out, okay, we can come back and edit this if need be. Okay, so let me say objective is to minimize my variable costs, and we'll say Z in dollars. Okay, so Z, my variable cost. Okay, first we'll look at the cost of hiring employees at the beginning of a month. So the cost of hiring a temp is $200. So my cost of hiring temps is going to be 200 times, okay, the number of employees hired at the start of month 1, at the start of month 2, at the start of month 3, and at the start of month 4. Okay, so we'll label this as cost of hiring. Okay, then I'm going to need to factor in the cost of firing. Okay, so this will be plus. Now the cost of firing is $400. Okay, $400. Okay. Now if I wanted to eliminate variables, so I can include them, but if I wanted to eliminate them, I know that I'm not going to fire any temps at the start of month 1, because I'm going to assume at the beginning of month 1 all I have is my permanent workforce, right? So I'm going to need to say hire temps to meet demand, but won't currently have any temps to fire. Okay, so Y1 should be 0. I don't need to fire anybody. Okay, and so in terms of firing, and again this is the beginning of the month, so I won't have any temps to fire at the beginning of month 1. So it'll be the temps fired in month 2, plus the temps fired in month 3, plus the temps fired in week 4. Okay, so I really don't have a Y1 variable because we're not going to hire or fire any temps at the beginning of month 1. But we can potentially fire temps at the start of month 2, 3, and 4. Okay, so this is cost of firing. Okay, now one thing I won't include is, you could say at the end of month 4, so beginning of month 5, I'd want to fire everybody. But we're not getting any information to project out beyond that, so I'm just going to leave it at that. And if we were to fire everybody, well, we could see what the effect of that is once we get to our Excel sheet if we wanted to. Okay, so this is our cost of firing. Okay, so I'm just going to focus on the 4-month period we're given. Okay, and then we have our inventory costs, so plus cost of storing our units, so $50 per month. Okay, so $50. Okay, and then that's variable WI, so that's storage at the end of the month. So I'll do W1 plus W2 plus W3. Okay, and then again we have a choice. Right? Ideally at the end of month 4, we don't have anything in storage. All right, so if we just imagined we had a 4-month period, but this is also very similar to kind of the idea of firing everybody. Okay, but we can include it. It's no big deal, right? So we can say plus W4 would be the cost of storing at the end of month 4. But ideally in this model, there is nothing left in storage at the end of W4 or end of month 4 that should just be 0. But that's something we can check. Okay, so this is our cost of storage. Okay. And yeah, that's it. And again, we could come back and revisit what would the effect be of making sure everybody's fired at the end of the month, but we can do that check when we get our solution. Okay. All right, so there's our objective function to minimize that. And now we're going to need to work on our constraints. Okay, so let's look at our constraints. Okay, so the first constraints I'm thinking about are demand. So I'm interpreting demand is the number of products that need to be delivered each month. Okay, so in terms of constraints, okay, the first batch I'm going to look at are going to be demand. Okay, demand each month. And so the demand in a given month, 520. Okay, so month 1 at 520 units. Okay, and actually, I'm going to do one more thing to simplify this. Well, I'm trying to think if I no. Let's okay. I'm going to introduce one more variable just for convenience. Okay, so not a variable. I'm going to introduce a few parameters for simplicity. Okay, so in our objective function, we're using variables x and y to correspond to the number of employees hired and fired at the beginning of the month. So as I was about to write down our constraint for demand, I have, say, 520 products I need to make. Some of those could be made by our permanent employees, but then we're going to have some that are going to be made by our temp employees. And so what I want to introduce is essentially a variable to simplify those constraints, which just corresponds to the number of temp employees at a given month. Okay, so we have X, Y, W, and Z, so maybe T. So let's let TI be number of temps at start of month. Okay, and so this is just going to help simplify my later equations. Okay, so if I think about month 1, okay, so we said we won't fire any temporary employees at month 1. Okay, so the number of temps in month 1, okay, T1, will just be equal to the number of temps that I hire at the start of month 1. Okay. Then the number of temps in month 2, okay, will be equal to the number of temps that I had in month 1, okay, plus however many temps I hire minus however many temps I fire. Okay, so I have like an employee balance. All right. So the number of temps in month 1 is the number of temps hired at the beginning of month 1. In month 2, it's the number of temps from month 1 that I'm starting with, plus the amount I hire minus the amount I fire. So month 3, T3 would be T2 plus X3 minus Y3. And in month 4, T4 would be equal to T3 plus X4 minus Y4. Okay. Cool. Okay, and this is where if I wanted to factor in to my cost equation, if I wanted to, force that everybody's fired at the end of month 4, I could add on to here or add into my 400 times y2 plus y3 plus y4. I could add in a T4, which would correspond to the would give me the number of employees or temps I have at the end of month 4. Okay, and again, we can see if that affects things when we play around with our Excel sheet. Okay, so I introduced some variables that correspond to the number of temps. Okay, so now I can work on my constraints. Okay, so in terms of constraints, okay, the first batch I'm going to work on is demand. Okay, so in month 1, okay, and I'm going to label them so I can keep track of them. My demand is 520. Okay, so that'll be equal to, okay, how many can my permanent employees make? So I have 10 permanent employees that can make 12 per month. Okay, a permanent worker makes 10 per month. Okay, so my permanent employees are making 10 times 12, 120, plus in month 1 I have T1 temp employees, and my T1 temp employees can make 10 each. Okay. And then let's see, so if I balance this out, I'm going to take it further. Okay, besides the 520 I'm going to deliver in terms of demand, the 520 I deliver in terms of demand, plus my inventory variable was W. Okay, so I'm going to do my demand plus the amount left in inventory at the end of the month is equal to the amount made by my permanent employees plus the amount made by my temps. Okay, and to simplify how I have my temps written, I'm going to rewrite this as 10 times T1. Now if I write out a balance for month 2, okay, I'm going to go find my demand for month 2, which is 720. So 720 plus the demand I have in month 2 is W2. Apologize. So that my demand in month 2 is 720 plus W2 is the amount left in inventory at the end of month 2 will be equal to the amount that I can generate using my permanent employees plus the amount generated by my temp employees, okay, plus, okay, on the right hand side I'm going to have the amount that I had in inventory at the end of month 1, which I would now have available at the beginning of month 2. Alright, so this is demand plus what's left in storage at the end is equal to the amount produced by my permanent employees plus the amount produced by my temps, plus what I had in storage at the beginning of the month. Okay, so now month 3, I have demand of 520 again. Okay, 520 plus W3, the amount left in storage at the end of month 3, is equal to the amount generated by my permanent workforce plus the amount produced by my temps plus that which I started with in storage at the beginning of month 3. Okay. Then finally in month 4 I would have demand of 620. So 620, okay. And then we said we would allow W4, we'll calculate its value. Okay, and this is where we can go and play with the Excel sheet. What if we were to force W4 to be 0? What if we just ignored W4 and assumed we didn't have any left, right? So if I were to remove W4 from there, all right, I just wouldn't include it here, and then I would make it so that I didn't have any demand left at the end of the month. Okay, and we'll play with this when we get things set up. Okay, so the amount made by my permanent employees plus the amount made by my temp plus what I had to start with at the beginning of the month. Okay, so I'm going to put W4 in there. Okay, so again, this is one of the questions we started up with up here. If I were to assume that I couldn't have any in storage at the end of month 4, right, I could just delete that there. Then W4 wouldn't be here, which would require that I balance this out at the end. Okay? All right. Okay, but my assumption is, or my thought is, this is going to be 0, right? Because that way that doesn't contribute towards my total cost, which I'm trying to minimize, since W4 doesn't help us at all, since we're not forecasting out to W5. Okay, cool. But we'll check that out in Solver. Again, we could have gone back and just set. Now I had a W4 there. We would have eliminated it in our last balance, but we didn't. Yeah. All right. So let's see. So there's our demand. So the hiring and firing is factors into our objective function. So we have the production rates in our constraints. Yep, we have our carryover. Okay, so then the only other thing it looks like we have would be our non-negativity constraints. Okay, so our non-negativity constraints would be that the number of employees hired in a given month has to be greater than or equal to 0. The number of employees, so we're not firing any employees in month 1, but the number of employees fired in a given month would also need to be greater than or equal to 0. And the number of units in storage at the end of a month would also need to be greater than or equal to 0. All right, and we said we couldn't fire any employees at the beginning of month 1, but if you wanted to, you could include it here, right? So if I were to include W1, I'd have T1. I don't start with any, so I'd have X1 minus Y1, okay, which would then allow for us to have a negative number of temps. So then I'd want to make sure that the number of temps in a given month was greater than or equal to 0. All right. So, but these are parameters. But that's something we can check in our solution, right? T1, T2, T3, and T4 should all be greater than or equal to 0. You can't have a negative number of temps. But yeah, so if I would have included Y1, I would have had an X1 minus Y1 there, and then I would have had included in here. But that's another thing we can play with to look at the effect when we set up our solution in Excel. Okay. Hope that helps. In the next screencast, we'll go and solve it. And again, we'll look at the effect of what if we would have included a Y1, what if we've included a excluded W4. And we'll solve in Excel. After I end this screencast, I'll summarize my system of equations below, and then we'll go over to Excel in the next video and solve. Okay, hope that helps.